Hello, today we're here with Daniel Povey, and our first question is, what is endpointing?
Uh, so endpointing is in real-time or online recognition, figuring out when the speech has ended, meaning when the person has finished talking. So the way that Kaldi does endpointing is pretty basic, but it does work. So we don't use things like the tone of your voice, like your voice might go down at the end of a sentence or something like that. It's purely based on the word alignment and the phone alignment and things relating to the language model. So basically, it's you can set these endpointing rules, and the rules have something to do with like how much trailing silence is there in the traceback. Is there a good final probability, meaning is end of sentence predicted with high likelihood, and things like that. So this page that you're showing here, this is the documentation for the C++ code. There are command line options that correspond to all of these things, and they're available in the I think it's like online-wav-something. There's a bunch of programs, but they have very long names, and they all start with online. So you can scroll down a bit. Yeah, so can you highlight that line that starts with contains non-silence? Okay, so you have to set, if you're going to do endpointing, you have to set at least one endpointing rule. Now, by default, there is one that is configured. This is all configurable by the command line, but you don't have to configure it. You can just leave it. So a rule gets activated if 5 different things are true. And reading from left to right, the first one is we're checking that something that's not just silence has been recognized so far. If the rule says must contain non-silence, then we're not going to trigger the endpoint if we've only seen silence so far. Now, the next part is about the length of trailing silence. Basically, you can set it to, let's say, 0.5 seconds. And then this rule will require that there's been at least 0.5 seconds of silence since the last thing was said. This relative cost thing, I believe that has to do with the probability of seeing the end of the graph, like the end of sentence probability. We're asking about the best traceback and what is the best cost of this best traceback versus the best cost of the best state available on the final frame that is final in the graph, meaning like it's an end of sentence state. And then the last part is a limit on utterance length, that we can have a minimum utterance length for declaring end of utterance. So that's it. It's possible to configure several rules, like you can configure 3 of them. And in that case, it's going to be an OR of those different rules, meaning if any of them triggers, then it's considered an endpoint. So yeah, thanks.
He just explained the 5 rules. And also, can I clarify, when you say the end of a recording, do you mean the end of a sentence or when like the person is completely done talking?
I guess I mean the end of a sentence. I mean, the thing is, I mean, it's very application dependent when you want to stop recording, and all you can really configure is these rules about how much non-silence there is, and like what the final probability in the language model is. It doesn't necessarily correspond to like a linguistic end of sentence, but most of the time it will. Yeah.
Okay, thank you. Our next question is, What is VAD?
So voice activity detection, it just means detecting when there's speech versus when there's silence uh, in a recording. And it's a little bit different from endpointing because in endpointing, I guess we're saying something about the future and about like the user's intention. We're saying that they've finished speaking, and it generally requires more complex information to figure this out, things like the language model or tone of voice. Voice activity detection is just simply, are they speaking right now? Yeah.
Okay, and also, when do we need endpointing and when do we need VAD?
Well, endpointing is needed in interactive real-time applications, things like Alexa, where some device is talking to you and it's got to decide when you finish saying what you want to say so it can process it. VAD is needed for all kinds of applications, but it can be used for like batch offline processing. It's not necessarily a real-time thing.
Okay, can you explain the main differences between VAD and endpointing?
Yeah, well, I think we mostly just covered that endpointing is it requires higher level information because it's something about the user's intention that they've said something and they've kind of finished their turn. And endpointing is generally done in real time, that you've got to say as soon as possible that someone has finished speaking. VAD is a more general term that just says we're detecting whether someone's speaking. It doesn't have any complex linguistic information like, oh, they've done talking now. That's not part of VAD.
Okay, thank you. That was Daniel Povey. Bye bye.